Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The state of stress at a point is shown with respect to the xy axis. Determine the equivalent state of stress with respect to the xy prime axis. Show the results on a sketch of an element aligned with the x prime y prime axis. So this is the given figure, and we use the transformation equation here this time to compute the state of stress with respect to the x prime y prime axis equivalent. So if you can recall, sigma x prime equals sigma normal equals quantity sigma x minus sigma x plus sigma y over 2 plus quantity sigma x minus sigma y over 2 cosine 2 theta plus tau xy sine of 2 theta. So again, sigma x prime or sigma normal equals quantity sigma x plus sigma y over 2 plus quantity sigma x minus sigma y over 2 times cosine of 2 theta, then plus tau xy sine 2 theta. So substituting with sigma x positive 40 and sigma y, because this is compression, negative 30, tau xy is 0, and 2 theta would be 2 times 30, so 60 degrees. So 40 plus negative 30 over 2 plus 40 minus negative 30 over 2 cosine of 60 degrees plus 0 sine of 60 degrees. So from here we can solve sigma x prime equal to 22.5 megapascal, so it is positive, so it is in tension. Likewise, for sigma y prime, uh, you just change the sign of the second term and the third term. So sigma y prime is equal to sigma x plus sigma y over 2 minus quantity sigma x minus sigma y over 2 cosine 2 theta, then minus tau xy sine 2 theta. So that when you add the two, remember the result is sigma x plus sigma y. Sigma x prime plus sigma y prime equals sigma x plus sigma y. So that it's easy for us to recall the formulas or equation. So substitute again. So we have 40 plus negative 30 over 2 minus 40 minus negative 30 over 2 cosine of 60 plus 0 minus 0 sine of 60. So we have 5 minus 35 cosine 60, so that would be negative 12.5 megapascal. So it is compression. Finally, for tau x prime y prime or tau normal tangential, it is equal to negative of this value, then this is sine theta, then minus tau xy plus tau xy cosine 2 theta. So tau x prime y prime is equal to negative of quantity sigma x minus sigma y over 2 sine 2 theta, then plus tau xy cosine 2 theta. So it's just copied here, then the sign here is plus, then interchange these trigonometric functions. Substitute tau x prime y prime equals negative of quantity 40 minus negative 30 over 2 sine of 60 plus 0. So tau x prime y prime is equal to negative 30.31 megapascal. So on the x prime face, it is downward as shown in the figure. So let's now align the results. So it is now inclined 30 degrees. These are the x prime, y prime axis, original x and y axis. So here we have 22.5 megapascals. On the y prime axis, negative 12.5, so compression. And the shear stress, negative, so it's going down here, going to the right, going to the left, going up. So that's the negative tau x prime y prime. So that's it. This is the results after we align the results, the equivalent state of stress with respect to the x prime y prime axis. The state of stress at a point is shown with respect to the xy axis. Determine the equivalent state of stress with respect to the x prime y prime axis. Show the results on the sketch of an element aligned with the x prime y prime axis. So here is the given figure. In this case, sigma x equals sigma y equals 0. And tau xy is positive, 55 megapascals. And 2 theta, because the angle theta is clockwise from the positive x-axis, it is negative 30 degrees. So 2 times theta is negative 60 degrees. Sigma x prime is equal to quantity sigma x plus sigma y over 2 plus quantity sigma x minus sigma y over 2 cosine 2 theta, then plus tau xy sine of 2 theta. So substituting, sigma x prime is equal to 0 plus 0 plus 55 sine of negative 60 degrees. So sigma x prime is equal to negative 47.63 megapascals. Likewise, sigma y prime is equal to sigma x plus sigma y over 2 minus quantity sigma x minus sigma y over 2 cosine 2 theta, then minus tau xy sine of 2 theta. Substituting, sigma y prime is 0 minus 0 minus 55 times sine of negative 60 degrees. So sigma y prime is positive 47.63 megapascals. Finally, tau x prime y prime is negative of sigma x minus sigma y over 2 sine 2 theta, then plus tau xy cosine of 2 theta. So substituting, tau x prime y prime is equal to 0, then plus 55 cosine of negative 60 degrees. So tau x prime y prime is equal to 27.5 megapascals. Let's now sketch the equivalent state of stress, aligning these values. So we have x prime y prime 30 degrees. So on this face here, we have compression negative 47.63 megapascals. On the y prime axis, positive, so tension 47.63 megapascals. And tau x prime y prime is positive, so it is pointing up here, up, down, left, as shown in the figure. So that's it for this problem. The state of stress at a point is shown with respect to the xy axis. Determine the equivalent state of stress with respect to the x prime y prime axis. Show the results on a sketch of an element aligned with the x prime y prime axis. So here is the given figure. This time sigma x is positive 60 megapascals, sigma y is positive 80 megapascals, tau xy is negative 100 megapascals, and 2 theta is 2 times negative 35, clockwise again, so negative 70 degrees. So sigma x prime is quantity sigma x plus sigma y over 2 plus quantity sigma x minus sigma y over 2 times cosine 2 theta, then plus tau xy sine of 2 theta. So substituting values, sigma x prime is equal to 60 plus 80 over 2 plus quantity 60 minus 80 over 2 cosine of negative 70 degrees plus negative 100 sine of negative 70 degrees. So from here, we can compute sigma x prime equals 160.55 megapascals positive sa it is tension. Sigma y prime is equal to sigma x plus sigma y over 2 minus quantity sigma x minus sigma y over 2 cosine 2 theta, then minus tau xy sine 2 theta. Substituting values, sigma y prime is equal to 60 plus 80 over 2 minus 60 minus 80 minus quantity 60 minus 80 over 2 cosine of negative 70, then minus negative 100 sine of negative 70 degrees. So sigma y prime is equal to negative 20.55 megapascals. Then tau x prime, y prime is equal to negative quantity x, sigma x minus sigma y over 2 sine 2 theta, then plus tau xy sine 2 cosine 2 theta rather. So substituting, tau x prime y prime is negative of quantity 60 minus 80 over 2 sine of negative 70 degrees plus negative 100 cosine of negative 70 degrees. So from here, tau x prime y prime is equal to negative 43.6 megapascals. So let's now show on the sketch the equivalent state of stress with respect to the x prime y prime axis and align these values here. So on the x prime y prime axis, we have tension 160.55 megapascals as shown. Y prime compression, so 20.55 megapascals. Then this is negative, so it's going down here. Left, up, then right, down to right as shown, with magnitude of 43.6 megapascals. So that's it for this problem.